In this lesson, we're going to look at flow rate and total time for IVs. I encourage you to use the strategy as I will teach it rather than the strategy that you will see in the textbook. So for our first example, ordered IV, 5% dextrose in water. We want it to deliver at 150 milliliters per hour. And our goal is to find the flow rate. In other words, what are the drops per minute? Now the tubing calibration is 15 drops per milliliter. The way we write that is 15 GTTS per ml. And our goal is to find the flow rate in drops per minute. And this comes down to unit conversion, as so much in this class does. So we begin with 150 milliliters per hour, which we will write as a fraction. And we would like to rewrite that in terms of drops per minute. So what do we know? Our tubing calibration is in drops per milliliter. So if we want milliliters to cancel, milliliters on the bottom, drops on the top, and we're saying 15 drops per milliliter. 15 drops per 1 milliliter. Notice at this point we have drops per hour. We don't want drops per hour, we want drops per minute. So we'll go ahead and we will convert hours to minutes. Hours is on the bottom. We want that to cancel, put hours on the top, minutes on the bottom. Of course, 1 hour is 60 minutes. At this point, milliliters cancel milliliters, hours cancels hours. We are left with drops per minute as our remaining variables. Multiplying this together, 150 times 15 divided by 60 is 37.5 drops per minute. If we want to round that to the nearest drop, that would be approximately 38 drops per minute. Let's take a look at another example. This time we'll say ordered. IV 0.9% saline. To be delivered at 100 milliliters in 30 minutes. And our goal again is to find the flow rate. But before we can do this, we need to see what our tubing drop factor is. And the tubing comes in at 10 drops per milliliter. And then find the flow rate in drops per minute. And then our strategy is to do the unit conversions. What we're starting with is 100 milliliters in 30 minutes as a fraction. 100 milliliters in 30 minutes. Now we can convert that using our tube calibration, 10 drops per milliliter. So we want milliliters to cancel. Let's put drops on top. What does that say? 10 drops per 1 milliliter. As milliliters cancels, at this point we have drops per minute, and that's all we need. So as those cancel, 1,000 divided by 30 is 33.3 drops per minute. And typically we round that to the nearest drop, so we'll go with 33 drops per minute. Let's do one more of this type of problem. This time we're going to say ordered. IV of 1,000 milliliters to run in 8 hours, to do this we need to know our drop factor, our tubing calibration. What is that drop factor? It is 20 drops per milliliter. That's the type of IV we're using. That's the speed with which it will be delivered, or the volume with which it will be delivered. 20 drops per milliliter. That's how big our drops are. And then the goal is to find the flow rate. And flow rate, typically we prefer to have that in drops per minute. But the process is done exactly the same way. We have 1,000 milliliters done in 8 hours. So we can convert that using our drop factor. We have drops per milliliter. So milliliter would cancel. Drops up here, 20 drops per 1 milliliter. As milliliters cancel, you can see now we have drops per hour. That's not what we're looking for. We're looking for drops per minute. So we need hours to cancel. Hours on top, minutes on the bottom. 1 hour is, of course, 60 minutes. As everything cancels, we are left with drops per minute. 1,000 times 20 times 1 divided by 8 times 60 comes up to be about 41.7 drops per minute. Which we will round to about 42 drops per minute. So if we use the unit conversion dimensional analysis strategy, these problems are relatively easy. Now, to change it, we could also ask what the total time is for a given IV. So let's examine total time. And we'll say ordered 1,500 milliliters IV. The drop factor this time will be 10 drops per milliliter. The flow rate is 50 drops per minute. And we're going to ask how long will the IV run. So you can see we're starting this time with 1,500 milliliters. And we want to see how long it will take for that bag to be emptied. So we want to convert milliliters into minutes. Now all we know is our drop rate. Our drop rate is 10 drops per milliliter. So we can get milliliters to cancel. Let's put drops on top. And our conversion factor is 10 drops per 1 milliliter. So you'll notice we have converted this from milliliters into drops. But then our flow rate can convert drops into minutes. So we want minutes on top, and we want drops on the bottom. This is the only thing that's a little bit challenging. It says 50 drops per minute, 50 drops per 1 minute. Now, we have this thing in terms of minutes, and frankly, that's going to be a very, very large number. So it may be helpful for us to convert that to hours. So let's put minutes on the bottom, and let's put hours on the top, and we can see what we get here. So as everything cancels, all that's left is hours. 1 hour is, of course, 60 minutes. All that's left is hours. So as we do our multiplication, 1,500 times 10 divided by 50 times 60, and the result that we get is 5 hours. So it takes 5 hours for that 1,500 milliliters in the IV to be administered. And let's take a look at one more question of this type in total time. So we're going to say ordered 1,200 milliliters IV. The drop factor this time is 15 drops per milliliter. And the flow rate is 50 drops per minute. So the question is, how long will this IV run? So we're starting with milliliters. We want to convert from milliliters to minutes or hours, whichever we prefer. So if that's the case, we'll go with 1,200 milliliters. And we can convert from milliliters to drops by using the drop factor. We want milliliters to go away. Put drops upstairs, and we have 15 drops per 1 milliliter. As milliliters cancel, we have now converted this to drops. How do I convert drops to minutes? We need drops to disappear. Drops will have to go downstairs to cancel. Minutes upstairs. And how many drops per minute? 50 drops in 1 minute. So as milliliters cancels, drops cancels, minutes is what's left. We could leave it in minutes, or we can convert to hours. I think I'll go ahead and I'll convert this to hours, again, because the numbers are fairly large. So 1 hour is 60 minutes. So everything cancels except hours. Doing the multiplication, what do we get? 1,200 times 15 divided by 50 times 60, and the result we get is 6 hours. So the running time is 6 hours for this IV. And that will conclude this lesson.